Hello, welcome to the NN Classroom. Today I'd like to share with you another question extracted from the Specimen paper 1 as well. So that is question number 11. Actually, question number 11 is not a super difficult one, and it is one of the really classic type of the question that always pop up in the IB examination. That is what we call definition type question. Definition type question is nothing special, but just obviously asking for you to know the specific definition. Just like in this case, they're asking for you whether you can understand the definition behind the kind of bonding idea. As they're asking, which is the best description of the ionic bond? That means you are asked to choose the definition of the ionic bond, right? So in this case, let's see. First of all, just remind you that before the definition, remember all of the bonds, the bonding, and also the what we call intermolecular force. In the IB syllabus, we will all define as electrostatic attraction. Electrostatic attraction. So that means all the definition related to bonding or intermolecular force in your IB question, if they are putting in the paper 2, ask you directly, remember to state the word electrostatic attraction. This is really critical. Not anything about nuclear attraction or other attraction, but electrostatic, the keyword, right? So here comes, they say, ionic bond, right? So in this case, ionic bond, which is talking about the electrostatic attraction between the oppositely charged ions. So in that case, which means cation and anion. So here comes something that is positive and something that is negative. So remember, this is also pretty critical. Whenever talking about electrostatic attraction, it must be between something that is positive and something that is negative. But just depends on the type of bond, the thing that is positive and the thing that is negative will be different. So in the case of ionic bond, the positive thing related to what we say cation, and the negative side is related to what we say anion, right? For B, for electrostatic attraction between positive ions and electron, that is to deal with the definition of metallic bond, right? So if you're clear about that, it is all because the metals, after they're losing the outermost shell electrons in order to attain the octet rule, so that's why all the metal become a positive ion, plus a sea of delocalized electrons. So that's why metallic bonds goes to the positive side to be cation, and the negative side the delocalized electrons, right? So that's why obviously the answer not goes to B, right? For C, electrostatic attraction between the nucleus towards the shared pair of electron in the bonding between the nuclei. Yeah, so in that case, that is to say the definition goes to covalent bond. Because covalent bond is concerning when nonmetals form bonds with another nonmetal, in which both sides wanting to grab the electron. So what do? They just put the electron in the middle and mutually share between each other. But the thing is, they are not really in favor of sharing electrons, right? In fact, they want to pull the electron from the other side towards its own side. So here comes attraction between the bonding nuclei and the shared pair of electrons. So again, something that must be negative and something that must be positive that they're attracting. So in the case of covalent bond, remember, it is the electrostatic attraction between the shared pair of electrons and the positively charged nuclei. Right, so that's why in that case, that is to say a covalent bond definition. Not we want, that is ionic bond, right? So finally, D, electrostatic attraction between nuclei. This is not really existing, not exist. Why? Because as mentioned, right, all the electrostatic attraction must be between something positive and something negative. So that's why if you are talking about attraction between two nuclei, that means two positive charge thingy. So that is impossible to have attraction, right? So D is definitely wrong, not even fulfilling any definition. So that's why the case now goes to A.